students. In today's lecture, we see one more theorem on differentiability. It is very important theorem of differentiability that differentiability implies continuity. That means this theorem says that every differentiable function is continuous. We have to prove this theorem using definition of differentiability. The statement of theorem is let f is a function defined from S is the subset of R into R. Okay, that is S is a subset of Rn. It's differentiable at A belongs to S. We have to show that f is continuous at A. That means we have given that f is a differentiable function at A, and we have to prove that that function f is continuous at A. That means differentiability implies continuity. Okay, let us start the proof. Let the function f is differentiable at A belongs to S. We know the definition of differentiability. If the function f is differentiable at A, then by definition, for epsilon greater than 0, there exists delta 1 greater than 0, and T is the linear transformation defined from Rn to R such that norm of h is less than delta 1 implies modulus of f of a plus h minus f of a minus t of h upon norm h is less than epsilon by 2. Okay, since the function f is differentiable, then by definition of differentiability, there exists a linear transformation R into R such that norm of h is less than delta 1 implies modulus of f of a plus h minus f of a minus t of h upon norm h is less than epsilon by 2. Okay, now T is the linear transformation which is defined from R into R. Okay, and every linear transformation is continuous. We learned this result in our previous classes or in FYBSc. Every linear transformation is continuous. As T is continuous at A, T is a continuous at A, therefore using definition of continuity, all of you know the definition of continuity. If T is continuous at A, then by definition for epsilon greater than 0, there exists delta 2 greater than 0 such that norm h is less than delta 2 implies modulus of T of A plus H minus T of A is less than epsilon by 2. Definition continuity तुम्हाला आठवतच असेल. T is continuous at A, which implies epsilon greater than 0, there exists delta 2 greater than 0 such that norm of h is less than delta 2 implies modulus of T of A plus h minus T of A is less than epsilon by 2. Okay, but now T of A plus h minus T of A is less than epsilon by 2, but T is a linear transformation. T is the linear transformation. So T of A plus H can be splitted as T of A plus T of H by property of the linear transformation. T of A plus T of H minus that T of A. So this both T of A minus T of A we cancel and we get that modulus of T of H is less than epsilon by 2. So in first equation we get this modulus of f of a plus h minus f of a minus t of h upon norm h is less than epsilon by 2, and the second equation is modulus of t of h is less than epsilon by 2. Okay, this is our given information. Okay, now we choose delta. Since here we use two deltas, delta 1 and delta 2, so we use delta which is minimum of delta 1 and delta 2. For this delta, norm of h is less than delta, and these two equations are also less than delta. That is modulus of f of a plus h minus f of a minus t of h upon norm h is less than epsilon by 2, and modulus of t of h is less than epsilon by 2. Not necessary of this step. Okay, modulus of t of h is less than epsilon by 2. These two equations are less than delta. For this delta, these two equations are less than epsilon by 2. Okay, now we have to prove that the function f is continuous at A. We have given that function f is differentiable at A, and we have to prove that this function is continuous at A. If the function f is we have to prove this function is continuous at A. That means we have to prove that modulus of f of a plus h minus f of a is less than epsilon. हे आपल्याला प्रूव्ह करायचं आहे. Modulus of f of a plus h minus f of a is less than epsilon by definition of continuity. So we consider this modulus of f of a plus h minus f of a. So we add the term positive t of h and minus t of h in this modulus. So modulus of f of a plus h minus f of a, we add the term minus t of h and subtract this term minus t of h plus t of h. Now we separate the mod. So this is less than or equal to modulus of f of a plus h minus f of a minus t of h plus the modulus of t of h. But modulus of f of a plus h minus f of a minus t of h, this term is less than epsilon by 2 into norm h. This term is less than epsilon by 2 into norm h, and this modulus of t of h is less than epsilon by 2, but norm h is less than delta. You know that norm of h is less than delta. Norm of h is less than delta. So norm of h is less than delta. So here we, this term epsilon by 2 into norm h is term is also less than epsilon by 2. So since norm h is less than delta here, or since we take here norm h is equal to 1, norm h ची व्हॅल्यू जर आपण 1 घेतलं फॉर दॅट norm of h is equal to 1 या व्हॅल्यूसाठी epsilon by 2 into norm h is equal to epsilon by 2 plus epsilon by 2 is equal to epsilon. That means modulus of f of a plus h minus f of a is less than epsilon. That means by definition of continuity, the function f is continuous at a. We have given that the function is differentiable, and we will prove this function is continuous at a. That means we get from this result every differentiable function is continuous. That means differentiability implies continuity. But converse of this theorem is not true. That means every continuous function is may or may not be differentiable. Okay, we will see this result in our next lecture. Differentiability implies continuity, but converse of this theorem is not true. Okay.